Hello everybody, welcome back today. And today we're going to be doing LeetCode number 75, sort colors. And yeah, let's just get into it. All right, so let's get started here. I'm going to explain this on my iPad. So what sort color wants us to do is basically you're given an array of zeros, ones, and twos where each of these numbers actually represents a color. And what we're trying to do is we're trying to sort them. So we're trying to put all the zeros at the start, then ones, and then twos. And also the thing is we cannot use the inbuilt sorting function of any of the languages. So in C++, we can just use the sort function that we're given. So how do we do this, right? And the thing is, like, we don't have to use any sorting algorithm here because if you think about it, we're restricted to three numbers, right? So we know that we can't have any other numbers in this array besides 0, 1, and 2. So a clever thing that we could probably think of is we're limited to like restricted amount of numbers, you can maybe just count them, right? So if we counted the number of zeros, so example, this one, there's two zeros, there's two ones, and then there's two twos. We count the number of number of times these numbers occur, right? The item count basically. We can just take this count and then just fill in the array, right? We can iterate one more time through the array and then we can fill it in. And this would give us a time complexity of O of n, right? And a space complexity would also be O of 1 because really, since it's only three numbers, we just need three variables here to keep track of the count. But the thing is, like, a lot of the times in the interviews, they're not gonna be just okay with the solution because while this is a good time complexity and space complexity solution, there's a really cool algorithm here that can be used to make this one pass instead of two pass. What I mean by that is here, what we do is we go one time through the array and we count the number of times these numbers occur, right? That's the first thing we need to do. And then we again go through the array and then fill in that array, right? So we're actually iterating through the array twice. But there's actually a very interesting algorithm here that we only need to iterate through the array once, and that's called the Dutch national flag algorithm. And so it seems kind of random, honestly, and might not be that useful besides this question, but it's really cool to see how essentially we're taking the two-pointer approach and we're extending it to three pointers. So to explain this, I'm just going to make an arbitrary array here, and just bear with me here. I'm just going to make random numbers, and this might seem like weird, like why am I setting it up like this? But it'll make more sense when we get into it. So let's just say I have something like this, right? This is my array. And what I'm going to do is I'm going to initialize three pointers, a low, a mid, and then I'm going to initialize a high, okay? And why I place these pointers here really matters. So the idea here in this three-pointer algorithm, if you want to think about it that way, is you assume that, like, let's just say from 0 to low, I have all my zeros sorted. From low to mid, all my ones are sorted. From mid to high minus 1, this is the section that is unsorted. So this is what we're going to actually try to solve. We're going to try to solve a smaller subproblem than the larger big problem of sorting. And from high and on to the end, the twos are sorted. So what's the idea here? Like, this just seems random. So what we're actually gonna do is we're gonna take this mid and we're gonna compare it, right? We're gonna check if is this mid one or is it 0, 1, or 2, right? There's three cases here. So if it's one, if mid, like the location at mid, if that's equal to 1, then we don't do anything. And why is that? Because if you check from low to mid, these are all ones. So this is actually already in the proper order because the whole idea is we know that this portion right here between mid and high is not sorted. If we can shrink this portion, that means we're getting it more sorted, right? So if it's a 1, we already know it's in the right position because we can just move our mid basically forward. So the thing is, like, if we see a 1, all we're going to do is mid plus plus. What I mean by that is we just move this mid pointer forward. If the mid is equal to 0, right? Then what does that mean? This actually shouldn't be here. This should be in the low section. So what we do is, like, we'll swap the mid and the low. So if this was a 0, this would get swapped here, right? And that would get swapped there. And what we do then is we swap, right? We swap low and mid. So I'm just gonna write that down here. Kind of as, like, not really pseudocode, but just like the idea behind it. So we swap them and then we move the low forward and the mid forward as well. Why do we move the low forward? Because we now know that low points to a 0. Because if we swap, that means this becomes a 0 and that 1 or whatever moves over there, right? And we know that low must start with a 1. So we have to move the low forward to the next one, right? Same thing. If mid is equal to 2, right? Then we swap high and mid, right? Now, here's the thing, right? When we swap high and mid, we're going to move the high back, right? So the high will move back because we're trying to shrink this location, like this subarray between mid and high minus 1. So we're going to move the high back. The thing is, we're not going to necessarily move the mid forward. And the reason behind that is like, let's say this is a 2, but like for example, high is not like is pointing to something like a 1 or something or a 0, right? Yeah, that could happen. Like this is just a hypothetical scenario where it's not happening, but in some cases it can happen. We don't know. Like this high location could be a 0 or 1, or yeah, 0 or 1. In that case, we might have to swap, and especially in the case of a 0, right? If we swap with a 0, that 0 actually needs to be moved back to the low, so we can't move this mid forward, right? Because otherwise we're just ignoring that part of the subarray. So we don't actually move the high here, but we do swap. And so this seems kind of weird right now, but this is kind of how it works. And we can dry run it on this example right here that they give us. I'm just gonna copy this down here. So in the real case scenario, low will start here, mid will start in the starting location as well, and then high will start at the end of the array, right? We're gonna check, is mid equal to 2? Mid is equal to 2. So then we swap with the high, and then we bring the high back. So what we're doing is we're gonna swap this right here. So actually I'm gonna write it down below so it'll be easier. So we swapped this, right? The 2 moved over, and then the high comes back, but the mid stays in the same location, remember? So low still points here, and the mid still points there, right? Now mid is equal to 0, so we're gonna swap, but they're in the same location. So essentially, I'm not gonna rewrite it, but mid just essentially moves forward, right? Because we swapped it, and then we just move mid forward, as we said right here. Say so, and then same thing here. Low also moves forward, right? So we're good here. Then again is mid. So now mid is again 0. So we're still again just at the we're still just gonna move in mid and low forward, right? So my low moves here and my mid moves here, right? Now mid is a 2, so I'm actually gonna swap with the high. So what that means is this will become a 1, this will become a 2, and my high just moves back. So my high is here now, right? And mid now points to a 1. So again, like we said, when it's a 1, we just move our mid forward because, again, we know that's in the right order because low to the mid should be just 1. So we know it's in the right order. So mid is now here. And again, mid is equal to 1. So we keep moving it forward. So once we are here, we see that mid has actually crossed high. So mid is now actually greater in the index location than high, right? Then we know we're done and we've sorted this. And as you can see, this is fully sorted array. And so yeah, let's now get into the code and it might make a little bit more sense there. All right, so let's get to the code here. So for sort colors, remember we talked about the Dutch national flag algorithm. So here I'm going to be using C++, but you can use any language. Obviously the logic remains the same, it's just syntax, but I prefer C++, so I'm going to go ahead and use it. But yeah, we have 3 pointers, remember? So one is low, and then we have the mid, but they both start at this first index in the vector nums array, right? And then we have a high, which is basically the end or the last element. So that's going to point to nums.size minus 1. And then I'm going to use a while loop to have this condition where mid is less than or equal to high. So we're going to keep doing this while loop until while this condition is met. And what this is saying is until mid is not crossing over high, which is what we talked about, right? We don't want mid to be past high. So we'll just keep running this loop. Then we have the case where it's like nums at mid. If that's equal to 0, then remember we talked about we want to swap with the low, right? Because we want the low pointer to point to 1s and anything before that to be 0s. So we can swap here, and C++ is an inbuilt swap. So this makes it a lot more cleaner in terms of the code, but you can just write a normal swap with like the temporary variable. It will also work. But yeah, I'm swapping the low, and remember we move the low forward because now once we swap, the low is going to be pointing to a 0, and then we want to make sure that the low is not pointing to any 0, it's pointing to a 1. So we just move it forward. Same thing with the mid, right? Because we want to shrink this window down, right? Next case is like if nums at mid is actually equal to 2. In this case, we want to actually swap with the high. Now, the thing about the high is it's not necessarily, oops, we want parentheses here. The high is not necessarily pointing to a 2 all the time. It might be pointing to a 1. It might be pointing to something. It might be pointing to 0, right? So in that case, we actually just want to move high down and not the mid forward because thing is like we can be shrinking both ways here because if the high actually has like a 0 and we swap it with the mid, and so now the mid is going to actually point to a 0. And if we move it forward, we just ignore that 0 because in fact, that 0 needs to be swapped with the low. So we can't be moving that mid forward, right? And then else, I'm just doing else here because we know that there's only 3 numbers here, and then else case has to be for a 1. We talked about it. The 1 must remain in the middle. So all we're going to do is move the mid forward because we're not going to swap it with any of them because it's in the right location. And yeah, if we run this should work. So let's just run these 2 test cases that they have here. Let's just make sure we didn't make any silly mistake. Yep, it's good. And this should work. And so yeah, you can see this is a very interesting algorithm. The problem was pretty simple if you just do like the normal way, right? With the two-pass solution, but the follow-up is what makes this a medium question than just an easy question. But yeah, I hope you enjoyed this video. Let me know in the comment section down below if you had any questions about the algorithm or anything you think that I missed. But yeah, make sure to like this video, subscribe to the channel, and I hope to see you on the next one.